Hello students, in today's lecture we'll see a problem on correlation coefficient with regression line. A problem is find the correlation coefficient between x and y for the following data. Also obtain the regression lines. The given data for x and y are: for x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y data are 10, 12, 16, 28, 25, 36, 41, 49, 40 and 50. So solution. So first we have to prepare a table, then we need to go for what here, summation of, that is x bar and y bar we need to calculate. So we'll see what is x bar and y bar. Now, so from the table, from the given question, we'll take the x values and y values. X values are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so then immediately we'll calculate summation of x. So summation of x will be 55 if you add all this. Similarly, the values of y will enter here, that is 10, 12, 16, 28, 25, 36, 41, 49, 40 and 50. So summation of y will be, so it will be 307. So we got this. So we'll go for x bar and y bar. So if you count these all data given in the question, so n values are 10 here. So we'll go for summation of x divided by n, that is x bar and y bar. So x bar formula is summation of x divided by n. So from the table, summation of x value is 55 and n is 10, so we'll get here 5.5. Similarly, y bar is equal to summation of y divided by n. So summation of y will got 307 divided by n value is 10. So if you calculate, so this will become 330.7. So both are in decimal, so we needed z bar also. So summation of z divided by n. So firstly we'll calculate. So because of this, these x bar and y bar in decimal, the coefficient of correlation is given by coefficient of correlation is r is equal to standard deviation of x square, standard deviation of y square minus standard deviation of z square divided by 2 times standard deviation of x, standard deviation of y. So here z is nothing but x minus y, and as we know that standard deviation of x square formula is, that is summation of x square divided by n minus x bar whole square. Fine. Then standard deviation of y square is nothing but summation of y square divided by n minus y bar square. And also we need to calculate standard deviation of z square is equal to summation of z square divided by n minus z bar square. So we needed a x square column, y square column and z square. So before z square we needed what here, z, which is nothing but x minus y. Let's go back to the table and first complete the table and we'll get the summations. So we needed z is equal to x minus y then x square column, y square column, z square column. So x minus y, z is x, 1 minus 10 is nothing but minus 9. Then next is, I'll write it, minus 10, minus 13, minus 24, then minus 20, 6 minus 36 is minus 30, then 7 minus 41 is minus 34, next is minus 41, 9 minus 40 is minus 31, and 10 minus 50 is minus 40. And summation of z will be in terms of minus sign, you can observe here. So it is minus 252. Then if you go for x square, so we'll get the values as x square. 1 square is 1, 2 square is 4, next is 9, 16, 25, 36, 49, 64, 81 and 100. Summation of x square will be 385. Next we will go for the y square values. So y square values are 10 square is 100, next is 144, 256, 784, 625, 1296, 1681, next is 2401, 1600 and 2500. So summation of y square will be 11,387. So finally we have to go for the last column, that is z square. So we need to calculate z square, all z values we have to square it. That is minus 9 square is 81, minus 10 square is 100, then next is 169, 576, 400, 900, all negative sign, but if you square it become all positive. Then 1000, 156, 1681, then 961 and 1600. So if you calculate the sum here, so sum of z square will be, that is summation of z square will be 7624. So we got all these summations. So first, with the help of this summation of z, we'll get back to the value of z bar, that is minus 252 divided by 10. We'll calculate first. So we'll calculate. So summation of z is minus 252 divided by 10. So we'll get minus 25.2. Now we'll come back to this respective formula what we have taken. So we'll fill the values here. So now again, so first formula, that is standard deviation x square or variance formula. So this is not a summation of x square, we got it as 385 divided by n value is 10 minus x bar value from the just now we have calculated, it is 5.5. So if you make it 5.5 square, so the answer will be 8.25. Similarly, if you calculate this, that is standard deviation of y square, so or variance, so it is nothing but, so summation of y square is 11387 divided by 10 minus 30.7 square, and if you calculate this value, so you will get 196.21. Similarly the last one, so summation of z square is 7624 divided by 10 minus it is minus sign, minus 25.2 square, so this is minus sign, but it will become automatically plus because we are scoring, so it will become 11.2854. so these values we got it. So these values we need to calculate here. So also, so for the formula, so we needed a standard deviation of x and standard deviation of y. So therefore standard deviation of x is nothing but, directly I am writing standard deviation of x from this, it is square root of 8.25, and standard deviation of y from this, it is square root of 196.21. so these two values will apply here and will get the r value. So therefore r is equal to, so standard deviation of x square, the value is 8.25 plus 196.21 minus standard deviation of z square, we got 11.2854 divided by 2 into square root of 8.25 into square root of 196.21. so from the calculator the solution of this is, so there is a small correction here, this value will, if you calculate, this value will be different here, just will calculate and tell you. If you divide 7624 divided by 10 minus 25.2 square, if you make it, so it will become 127.36. okay, this is the correction here. So here also it will become 127.36. if you calculate this all, so you can see here, so if you apply all this value, will get 0.9582. so it will become, r will become here 0.9582, or r will be equivalent to 0.96 is the required coefficient of correlation. But in the question they have given, we also need to find the value of regression line. So we'll see how to find the regression line now. So we'll check, so regression lines. So as you know that regression line, we have y on x and x on y. So I will take y on x. Okay, so regression y on x, the formula we know that y minus y bar equal to r into standard deviation of y divided by standard deviation of x into x minus x bar, and also x on y, regression line x on y will be x minus x bar equal to r into standard deviation of x divided by standard deviation of y into y minus y bar. So these are the two regression line, y on x and x on y. So we know all these values, we have to fill it. So y minus y bar value from the table, it is it is 30.7 is equal to r value, just now we got it, we have calculated, it is 0.96 into standard deviation of y. So standard deviation of y, it is nothing but square root of 8.25. okay, just I will show you. So standard deviation of standard deviation of y is 196.21 and standard deviation of x is 8.25. we have to correct it. So this standard deviation of y is square root of 196.21 divided by standard deviation of x is square root of 8.21 into x minus x bar value. So x bar value we got it 5.5. Fine. So we'll calculate. So y minus 30.7 will keep as it is. First we'll calculate this. So if you calculate this value in the calculator, that is, I will take first 0.96 into division square root of 196.21 divided by square root of 8.21, and if you see that, it will be 4.69. I will take two decimal place, 4. So this value will be 4.69. I will take two decimal place into x minus 5.5. So therefore y minus 30.7 equal to, open the bracket, 4.69 into x, plus into minus is minus. So 4.69 into 5.5, 4.69 into 5.5 will be 25.795. Okay, so shift this minus 30.7 to the right hand side. So y is equal to 4.69x minus 25.795 plus 30.7. So we'll get, so it will become 4.69x minus, if you use minus 25.795 plus 30.7, it will become, if you take two decimal, 4.91. So this is a regression line y on x. Similarly, already we have taken here, so this will calculate now. So if you apply the x bar value and r value, standard deviation of x, standard deviation of y, and y bar, will get it as, and x minus x bar value is 5.5 equal to r value is 0.96 into square root of standard deviation of x is, we have taken as 8.25 divided by square root of 196.21 into x minus y minus y bar is 30.7. So if you calculate this again, so x minus 5.5 equal to, so if you calculate this, 0.96 into square root of 8.25 divided by square root of 196.21. So we'll get this answer as 0. I will take 3 decimal here because 9 is coming, 0.197. 0.197 of y minus 30.7, that is x minus 5.5 is equal to 0.197y minus, if you multiply 0.197 into 30.7, so up to 2 decimal place I will consider as 6 point, or else whatever we'll get, we'll take as it is 6.0479. So therefore x is equal to 0.197y minus 6.0479, if you shift it, plus 5.5. So if you calculate, this will be x is equal to 0.197y, and if you subtract, that is minus 6.0479 plus 5.5, will get the answer as minus 0.548. So this is the second regression line. So in this way we need to calculate for the regression lines here. So there is a small correction, actually this is 5. 8.25. so if you calculate, so this will become 8 and a small correction you will get it in the final result. So instead of 9.1 you may find here 9.6, so this will become 9.8. okay, and this will become 4. okay, so if you calculate you will find this. You cross check once again. So 4.96 and this y is equal to 4.69x minus 4.96, one regression line, and x is equal to 0.197 y minus 0.548 is another regression line. So y on x and x on y. So in this way we need to get the regression lines here. Please subscribe the channel, like the videos and press bell icon to get updated videos.